So my dear students, today we are about to discuss Archimedes Principle, very important topic of 10 plus 1. It would also enable you to manage your MCQ type questions. So Archimedes Principle is when you put something, any object into a fluid, can be liquid or maybe in the gaseous form. So an upward force is experienced, that is weight inside the liquid, inside gas appears to be lesser. So let us prove it, let us find by what amount the weight gets reduced. So when this object was not present inside water, say this is water, and this portion is say an object that is maybe a cylinder made up of say iron. So iron cylinder is put into water. Let us see what are the forces which water would exert on the cylinder. Since we are totally focused on the weight of the object, so we will consider the forces acting on the upper face and acting on the lower face, because sides would also experience a force due to pressure of the liquid, but those forces are horizontal, this way, they are not going to affect the weight of the object. So weight is controlled by the forces of pressure on the top and the lower face of the cylinder. For easiness, for making the treatment convenient, easy to learn, we have taken cylindrical object. But whatever we'll discuss, that is applicable for spheres, that is applicable for a cuboid, that is applicable for any irregular body. You put a potato into water, same result would hold good. So what is the principle? First of all, principle is if you put an object made up of anything into water or a gas, that is any fluid, in that case the object experiences an upward force known as upthrust, also known as buoyant force, which makes the object feel a little lighter in water. And we people also, when enter into water, swimming pool, we start feeling that our weight is very small, and that small weight can be managed by making our hands and legs, arms and legs move, and that is known as swimming. So swimming is possible because of upthrust exerted by water of the swimming pool on us. So how much is the force? That is what Archimedes principle is about. Archimedes principle first of all states that the buoyant force or the loss in weight of an object which is partially or completely immersed into a fluid is equal to. So whenever something is put into water, it would feel lesser weight, and the amount by which the weight gets reduced, the loss in the weight, is equal to weight of the fluid displaced. Weight of the fluid displaced. Now what does it mean, fluid displaced? Earlier, the portion where I have shown the cylinder, this portion was occupied by water. When the cylinder has come in, this much of portion of water has been pushed out, has been displaced. So whatever volume of water was present here, which has been displaced, the weight of that water is equal to loss, that is upthrust, experienced by this cylinder when placed in the liquid. So if weight of this cylinder was suppose 20 Newton in air, when it was present in air, weight mg was 20 Newton. When put in water, its weight becomes say 15 Newton. Reason, whatever volume the cylinder possessed, if we had a cylinder made up of water exactly of same volume, then that quantity of water would weigh 5 Newton. So 5 Newton is the loss in weight. That is, new weight of the cylinder inside water is 15 Newton. So this 5 Newton is exactly equal to the amount of the liquid displaced into G, mg, weight of the fluid displaced. Hope principle would be clear. Loss in weight of an object which is either completely or maybe partially put into water, the loss in weight is equal to exactly the weight of the liquid or fluid displaced by it. Now we have to prove it. Why is the loss or the buoyant force equals the weight of the fluid displaced? Let us say density of the fluid is sigma, density of object is rho. So pressure increases with depth, yani pressure at point P2, at point 2 pressure is P2, at point 1 pressure is P1. The difference of pressure due to depth, as you move deeper into a fluid by distance h, the difference of pressure equals h rho g. So we are going to use this relation. Here the density of the fluid is sigma, so I replace this rho by sigma. The derivation in which you had variation of pressure due to depth, that outcome is P2 minus P1 equal to h rho g. Pressure at point 2 is greater than pressure at point 1 by h rho g, where rho was density of the fluid, but now the density of fluid is replaced by sigma. So let us see what are the forces additional to weight experienced when this cylinder comes into water. So let us say area of the base is equal to A, pressure experienced due to water P1, and pressure experienced at point 2 is P2. So an upward force P2 into area. Since pressure equals force by area, that means force equals pressure into area. So downward force experienced is P1 into A, whereas upward force experienced is P2 into A, but P2 is greater than P1, that is the force experienced due to this difference of pressure is P2 minus P1 into A. But P2 minus P1 is H sigma G into A. But area of base into height of cylinder is equal to volume of cylinder. Now this volume means two things. One, volume of the given cylinder. Also it is equal to volume of displaced water. So A into H, let me write here, the buoyant force experienced is A H sigma G, where A into H is volume, but we'll have to write it as volume of the fluid displaced. So let me write a suffix D, which means volume of water displaced. Since volume into density, volume of water displaced into density of water would be equal to mass of water displaced into G, and M into G equal to weight of water displaced. So once again, the cylindrical portion inside water, in addition to its weight I haven't taken into account yet. In addition to weight, the new forces which have come up when it enters into water, one is P1 into area, another is P2 into area. P1 into area, P2 into area. But as you move deeper into a liquid, deeper into a gas, pressure keeps on increasing. So force from downwards to upward direction, that is equal to P2 into area. Upward to downwards, that is pressure on the upper face into area, P1 into area. So subtract the larger one, smaller one from the larger one. P1A is smaller, P2A is larger. So P2 minus P1A is the net force which water applies in upward direction. So A taking a common, P2 minus P1 into A, P2 minus P1 is H into density of the fluid into G. So area into height, area of base into height is volume of cylinder. It is as well as volume of the liquid displaced. Volume into density equals mass of the liquid displaced, and mass into G equals weight of liquid displaced. So that is what we were supposed to prove, that the loss in weight, that is the upward force, that is the buoyant force which the cylinder experiences due to buoyancy, due to pressure difference, is equal to weight of the liquid displaced. That is Archimedes principle. Now sometimes we may be required what is the net weight of the object inside water, inside the fluid. So that weight would be called apparent weight. Apparent weight means which appears to be. That is equal to true weight minus buoyant force. Now true weight is volume of the cylinder, V into density of cylinder, rho into G. Volume into density is mass, mass into G equal to weight. Whereas buoyant force is equal to same volume into density of liquid into G. You may take V common, you may take G common. Inside you have density of object minus density of liquid. You can multiply and divide by density of object. Multiply by rho, divide by rho. Rho by rho 1 minus density of liquid by density of object. So this portion you can write as true weight into 1 minus sigma by rho. This is the formula for apparent weight. So there are two possibilities. Density of object is larger than density of liquid, the weight turns out to be positive, the object sinks. If density of object and density of liquid are same, weight apparent is 0. The object can stay anywhere, wherever you leave inside the water or other liquid also. In case the density of object and density of fluid are same, like a helium filled balloon keeps rising up, but beyond a certain point it doesn't rise, because as density of surrounding air decreases with height, when the density of air and density of balloon become same, after that balloon stops rising up. In case density of object is lesser, like wood placed in water, the net weight experienced would be upwards, negative. So you leave a piece inside water, it will experience more upward force than its weight. As a result, it rises to the surface of the fluid. So I think I am able to clear you the idea. So when an object is placed inside a fluid, liquid or gas, there are some forces acting in vertical direction. Because of difference of pressure, pressure increases with depth. So this force, that is P2 into area, is more, P1 into area is smaller, which results in an upthrust, a buoyant force, and which is equal to weight of the liquid displaced. Thank you for watching.